we talked about, or the last couple of days, we talked about dilations and how dilations create similar figures. Today we're going to talk about similarity transformations, and a similarity transformation is any combination of rigid motions, so in the past, rigid motions are translations, reflections, and rotations with a dilation. Okay, so we might do a reflection and then a dilation, or a dilation and then a translation. So some combination of transformations with a dilation. Okay. And whenever we do a rigid motion with a dilation, the resulting image is always similar to the pre-image. A congruence transformation is any combination of rigid motions, so again, translations, reflections, and rotations, with no dilations. Okay. So whenever you do a transformation, big important thing to remember, and you do a dilation, the pre-image and image are always similar to each other. Whenever you do a combination of transformations and there's no dilation, the pre-image and image are always congruent to each other because you're not changing the size. Everything's staying the same. So just like we did last unit, we can combine multiple transformations in one problem. So now we're going to do multiple transformations with a dilation. So this first example, we are going to graph the image of this triangle using a dilation with a scale factor of 2, followed by a rotation of 90 degrees counterclockwise. So whenever we do a dilation, we'll go ahead and write down those vertices. So A is at -4, 4. B is at -4, -3. And then C is at 4, -3. So go ahead and write down those vertices. And whenever we do a dilation, we've been talking about the last couple of days, what are we doing with the scale factor and the points? Okay? Oh, thank you. Oh, negative. Whenever we do a dilation, what are we doing with the scale factor and those vertices? What do we have? Okay. Yeah, very good. We're multiplying. So all we're going to do is just take each of those vertices and multiply them by 1/2. We get A prime, B prime, and C prime. Remember, it is important to go in order. So it said to do the dilation first, so we have to do the dilation first. Actually, when we multiply that first point by 1/2, what's our new point going to be? Just multiply both the x and y by 1/2. Gabe, when we multiply the second point by 1/2, what do we get? Good, -1.5. You don't have to write it as a fraction. It's actually easier if you write it as a decimal because 1.5 is easier to tell on the graph than a fraction. Yes. Oh, I'm thinking of the next one. I'm sorry. I'm like 2 examples ahead. Whoops. Sorry, change that to a 2. Redo that. Sorry, when we multiply A, actually I'm going to go back to you. When we multiply A by 2, what do we get? Good. -8. Back to you, Gabe. When we multiply B by 2, what do we get? -6. Okay. And then when we multiply C by 2, Alyssa, what do we get? Good. -6. Okay. And it's great when you do a dilation and a rotation together. You don't have to plot that second set of points. Save yourself some time. You can if you find it helpful, but there's no need to because when we do a rotation, we just have to know what the points are. So whenever you do a combination of a dilation and a rotation, you don't have to plot these purple points. Again, you can if you want to. It is more work. So we can go ahead and write into our rotation. So when we do a 90-degree rotation, Bree, what is the rule for when we do a 90-degree rotation?
You have to swap the things.
Good. Yeah, the X or the first. I know what you're talking about when you say X. Yep. So flip your points. I like to flip first. And then go through and change the sign of the first. So the positive 8 becomes negative. That becomes positive, and that becomes positive. And then those orange points are your final answer. Okay? So we don't have to see the purple points graphed, but I do have to see those final points. So we have to plot those orange points. So go ahead and plot them. -8, -8, 6, -8, and then 6, positive 8. And connect. So that was A prime, or double prime, C double prime, and C double prime. Make sure you label your points. It helps me know what you think the final answer is. And if you do make a tiny little error, it helps keep your work organized. So I can recognize that error a little bit, but if the points are labeled, it's hard to follow. Just make sure you're labeling your points. Are the pre-image and image similar or congruent? Good. How did you know they were similar?
One's obviously a lot bigger.
Good. One's a bigger, one's smaller. But just because they're different sizes doesn't necessarily make them similar. What specific thing did we do? Well, rotations don't change the size. What transformation did we do? Carter? We did a dilation. So our reason why they're similar is because we did a dilation. And a dilation always creates similar figures. So again, if you rotate or reflect or translate, but there's a dilation somewhere in there, you're always creating a similar figure. Every time. Questions over that? Take a look at the next one. B says a translation, right 2 and down 4, followed by dilation with a scale factor of 1/2. That's where that 1/2 comes from. I was thinking of this one. So go ahead, do the translation first. You're just taking each vertice, moving it right 2, and then down 4. 2, 3, 4. Right 2, 1, 2, 3, 4. 1, 2, 3, 4. Then label A prime, C prime, and B prime. Then we have to do the next transformation, which is our dilation. So just like we did on the last one, we write those new points down. So I'm going to write A prime, which is going to be 2, 0. B prime, which is -2, -7. And then C prime is at 1, 2, 3, 4, 5, 6, -7. And we're going to get our new points. C double prime and C. And Sebastian, whenever we do a dilation, what do we do with those points in our scale factor? Good, we multiply. So we're multiplying all these points by 1/2. So we multiply A prime by 1/2. W, what do we get? Naomi, what do we get? We multiply -2 times 1/2. That gives us what? Good. Good. -1. And then what's 0 times 1/2? 0. Good. Then what do we get when we multiply B prime by 1/2? Zoe? Good. -3.5. And again, it's okay to write it as a decimal. I encourage you to write it as a decimal. Because as a fraction, that's -7/2, and that's harder to tell where it is on the coordinate plane. But if you write it as a fraction decimal, it's easier to tell. And then when we write C, what do we get, Nyla, when we multiply C by 1/2? Okay. And then we're done. So we just plot our new orange points, label, and that is our answer. So we have -1, 0. When you have a decimal, -1, -3.5, just estimate. So we're going to go to -3 and just go about halfway between -3 and 4. Just estimate. It's okay if it's like a teensy bit closer to one or the other. And then +3, -3.5. A double prime, B double prime, and C double prime. Lewis, was the pre-image and image similar or congruent? Good. Similar. Why was it similar? Good. It became smaller. What made it become smaller? What transformation? Good. We did a dilation. We did a dilation. And they always create similar. If you notice, for B, was our scale factor bigger than 1 or smaller than 1? Smaller. What happened to our figure? Yeah, shrink. Became smaller. If you notice with A, what was our scale factor? Was it bigger than 1 or smaller than 1? Bigger. And what happened to our figure? Increase. So remember that if it's going backwards, then go back and check your work, because maybe you're dividing instead of multiplying. Okay, 2 more. We take a look at C. C is a reflection over the line y equals x, followed by a translation left 6, then up 4. Okay? When we graph the line y equals x, where do we always start at? We start at the origin. Very good. Start at the origin. And then what slope do we follow? Good, up 1 over 1. So we're going to write down the middle of our graph. Up 1 over 1. And then down 1 over 1. Just going right down the middle. Okay. So when we reflect over the line y equals x, I'm going to start with point C. I'm going to count up till we get to that line. And I counted up 1, 2, 3, 4, 5, 6, 7. To get C on the other side of that line, Ryan, which direction are we going to go? Are we going to go right 7 or left 7? Good. We're up 7, we're going to go left. 1, 2, 3, 4, 5, 6. And that's C prime. Again, think you're making a right angle with that line, and the line's going right down the middle. Okay? So then with B, I went down 1. Parker, if I went down 1, am I going to go left 1 or right 1? Good. Go right 1. And then Josh, with A, I went down 1, 2, 3, 4, 5, 6, 7, 8. Am I going to go left 8 or right 8? Go. Right. 1, 2, 3, 6, 7, 8. Then we do our next transformation, which is a translation left 6, then up 4. So then just move everything that direction. All the points are going to go left 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 1, 2, 3. And we're done. Oh, I did. Oops. This one's it. Thank you. So that would be it. Yep. This one's A, and then that one would be A. Yep. image similar or congruent? Think, did we do a dilation? Nope. So then they have to be what? They have to be congruent. Good. They have to be congruent. And your reasoning is no dilation. We did not do a dilation. We only did rigid motions. So they have to be congruent. Questions over that? If we take a look at D, it says a rotation 270 degrees counterclockwise, about the origin, followed by a dilation with a scale factor of 1/4. So again, we're doing a rotation. Write down those original points. So A is at -4, 4. B is at -4, -3. And C is at 4. Brooklyn, when we do a 270-degree rotation, what do? I like to flip first. So when we flip, again, just switch the numbers first. And then go through, change the second. That's going to become positive, that becomes positive, and that becomes negative. When we do a rotation with a dilation, do we need to plot those second points? Is it necessary? Just go ahead and do your dilation. Double prime, E double prime, and Brandon, whenever we do a dilation, what do we do with the scale factor and the points? Good. We multiply. So we're multiplying all these green points by our scale factor. And again, if you don't get a whole number, just write it as a decimal. So when we multiply, Trent, what do we get when we multiply A by 1/4? Good. 1 and 1. Good. Okay. Celeste, what do we get when we multiply B by 1/4? We're going to get a decimal. Good. -0.75.
And 1.
Good. And then when we multiply C by 1/4, Chris, what do we get when we multiply C by 1/4? Think what's -3 times 1/4? 3/4. What's 3/4 as a decimal? Think how many cents are 4 quarters? Or 3/4? 75. Good. So that's -0.75. And then what do we get when we do -1/4 times? And then we're done. Then plot your new points. Again, this is really tiny, so just do your best. My smart board makes it look a little floppy. So -0.75, that's just really, really close to 1. So again, just estimate. It's okay if it looks like it's almost on there. As long as you show your work, I'm going to know you graphed that correctly. And then -7.5 at 1. So this is really teeny tiny. C prime. C prime. Really teeny tiny triangle. Question over that. Logan, is the pre-image and image similar or congruent? Similar, good. What did we do that made those similar? What transformation?
Dilation.
Very good, we did a dilation. Right? We did a dilation, and dilations always create similar figures. Questions over that? We'll do one more and then time to practice. Just due to time, we'll do this one tomorrow. But let's talk about example 3. Okay. Example 3 says triangle ABC was transformed to produce triangle XYZ. Select all the transformations that would guarantee that triangles A, B, C, and XYZ are congruent. Meaning, what transformation can we not do? dilation. So we have to circle all the ones that do not have a dilation. So which ones are we going to circle? Good. C doesn't, D doesn't, and F doesn't. E, B, and A all have dilation in it, which means we're creating similar figures. And that's not what we want. Questions over that? No? We will finish the rest of that up tomorrow.